So, good evening, everyone. For those of you who don't know me, my name is Lakmal Caldera, and I'm a front-end application developer here at Creative Solutions. And welcome to my TechTalk. So we're going to be focusing mainly on the prototype-based programming model as opposed to class-based programming model, which I'm sure a lot of you guys are familiar with. Now, before I get started with the presentation, I just want to say I just want to bring up the flyer for this TechTalk, which was distributed earlier this week. And I want to point out a small clarification here. If you follow the laser pointer, I made a small mistake here. I just want to clarify that others will feel so guilty. So I mentioned in the second paragraph. If you follow the red dot on the presentation, you'll see you'll read out that the language of choice was not by preference, was JavaScript, not by preference, but it's not actually JavaScript. It's not actually JavaScript that went mainstream and became so popular. It's actually ECMAScript. JavaScript is nothing but a combination of different APIs written out in the language ECMAScript. Okay? So with that said, I'm going to start my presentation. Today's TechTalk, and I'm going to start off by talking about why JavaScript is so flexible and all the different programming models it offers us, and then we'll do a quick comparison between the prototype model and the classical model, and then we'll look at functions, objects, some of the internal properties, and how all these properties connect to form the bigger picture. At the end, towards the end of the presentation, we'll quickly take a look at the object hierarchy. We'll look at the object hierarchy, and then finally we'll look at prototypal inheritance and speak a bit about object typing. So JavaScript is a very flexible language, as you all probably know. Right now, one of the reasons that makes it such a flexible language is that we can choose to program in any of these styles. We have object-oriented, which is very popular among everyone, functional, and imperative, right? So JavaScript allows us to combine all these three programming models to write code that is very flexible and very high performing. So in this TechTalk, we're going to be focusing mainly on object-oriented. So another reason why JavaScript is considered to be a very powerful object-oriented programming language is because it supports all the concepts of OOP, which you're all very familiar with. Yeah. Now, some people might not agree with that, mainly because the language itself doesn't provide native support for those concepts. But and some might even call that kind of approach hacks. If you want to implement concepts using JavaScript, yeah, it might be a hack. It probably is, but that's how you go about achieving those concepts. Mainly because you combine object-oriented and functional at that point, and it gets really confusing from there. Which is one of the reasons why a lot of programmers don't actually appreciate this language. Programming. So the programming model is not the normal model you guys are used to, which is classical. We're going to look at that model now. And so object-oriented comes in two basic flavors: the classical model and the prototype model. The prototype model is what's being implemented by ECMAScript, and and all other languages that are compliant with this specification, such as JavaScript, Node.js, ActionC. So I know you guys probably coming from a classical class-based background, right? And you guys are probably you guys probably think you know all the basic concepts and. I mean, yeah, but when you come to this model, it's a completely different approach to how you need to view these concepts. It's if you need to understand the prototype model, which is the first step to writing any kind of code, and that's what I'm going to help you guys with in this talk. Yeah. So object-oriented programming. So I have basically summarized the differences between class-based model and prototype-based model here. And the most basic, most significant difference between these two models is that class-based model has the notion of classes, and you instantiate objects out of classes. But in the function, in this prototype-based model, you don't have classes, which is why it's called prototype-based model, right? And you guys don't need to go through this and memorize it right now, because I'm going to take you through each and every one of these in the following slides. And this is a typical comparison which a program would generally do between class-based and prototype-based models. We have what we call the class onto our left here, written out in Java. It's very simple. Yeah. And in JavaScript, you don't have the concept of classes, right? So all you have is functions, and these functions are objects. In JavaScript, when you write functions, right? They get converted to objects before execution of code begins. So I want you guys to start thinking of these functions as objects. Yeah, I encourage you to start thinking like that. Object. So the next one is constructors. Now in class-based model, we have a constructor as a method in the class, right? And what the constructor does is it calls its superclasses constructor, and it goes on. But in JavaScript, we don't have any such supercode, because mainly the function itself is considered the constructor. Yeah. And here's just an example for you guys to see the function itself is the constructor, and there's no other method in there. So how do you instantiate objects in both these models? They both work the same way. We make use of the new keyword, and here's a comparison how you do it. I'm instantiating a Java object onto my left, and I'm instantiating a function object, an instance in JavaScript there. So they're both pretty much the same. They follow closely. Now, however, even though they look the same, the real what really happens behind the scene can be slightly different. Which is what we're going to look at now. So here's the Java model, right, where you have a class where you instantiate an object. It makes those sequential calls to its superclasses and creates the instance, right? And all the attributes on that class, all the instant attributes at least, it's passed on to the object directly from the class. So that, as compared to what we have with JavaScript, in JavaScript we have a function, and this function, don't get confused with this function, even though it looks like a UML diagram. It's not actually a UML diagram. It's actually an object. I just do it out like that so you guys would be able to tell the difference between this and the objects means we are going to instantiate out of this function. So JavaScript has a totally different policy. It doesn't add all the attributes of a class into an object, right? What JavaScript believes is isolating the common state and common behavior particular entity and basically isolating that behavior into a separate object. And when you instantiate objects out of a function, what you get is all the specific behavior specific to that function. So I have this diagram here. So that's the object, yeah, where every function gets this object. It's a very special object, and that's where it stores all the behavior that is common to all instances you would create out of this function, right? And what it does is, as a programmer, you're responsible for isolating all the common behavior and common attributes which would be common to all the instances, yeah, into that object. And when you create a new object with that new keyword, right? So you get these objects, and all the specific attributes are added onto the new instances, right? The common functions and common state, everything is stored in that separate object. And if the new instances want that particular attribute or common behavior, it's going to have to consult with that object, the functions object, and get it, basically. So that's the idea behind how an instantiation happens in JavaScript. So and that object is what we call prototype object. So it's very important for you guys to understand that every function has an associated prototype object with it. I have placed an asterisk on top of that arrow to indicate that it's actually a pointer. So it's a pointer, and every function has an object. Yeah? So inheritance. Well, the bigger picture here might look somewhat similar, even though we have two different names for both these models. We call inheritance in class-based model classical inheritance. Yeah, classical inheritance, and in JavaScript, in this prototype-based model, it's called prototypal inheritance. But the concept is pretty much the same. When you instantiate objects from classes, you get a model as you see over here on your left. Yeah, and you inherit your attributes and methods from objects, right? In JavaScript, you have the same model, but in reality, even though you're inheriting it from objects themselves, the objects that are involved here are totally different, and it's not really instances. It's really prototypal objects. We'll talk more about how prototypal inheritance happens in the coming slides. So class-based model is it's not flexible, and prototype-based model might be too flexible. This could be a mixed opinion on people, but the idea is in JavaScript, once you write a class and once you instantiate an object, you can't actually modify it in the sense that you won't be able to add properties on the fly when you're programming it, and you can't actually change it. But you can actually do that. You can pretty much change everything with objects in JavaScript. You can because they're all pointers and they're all live pointers. You can change behavior, add functions, add methods, whatever. So now that we covered the comparison between the two models, I'm going to talk a bit more about what functions are in this language. Functions are basically objects. Like I said before, when you write out a function, before your code even begins executing, those functions are converted to function objects. And sometimes they're called constructors. Now, if it's an object, it should have a constructor itself, right? So that constructor is a native constructor you find in the language, and the name of that constructor is function itself with capital F. So here's a small example I have where if I write out code like that, what JavaScript would do is it would invoke new function like that, like so, and it would create an object, and that object would be a constructor. So using that function object, we can choose to create no objects. So now we spoke about on function objects as constructors. But what are these objects you would instantiate, right? Now typically the difference between these instances you would instantiate out of a function and these normal objects, so object literals, as you see there. Those are just empty objects. Those are just empty objects, and they can be instantiated by invoking a new one on another native function called object with a capital O. So all objects inherit from this native object because it's kind of the base object. It's kind of base object and it's sitting on top of the object hierarchy tree. And the main difference between this and function objects is that these objects don't behave as constructors, and you can't actually instantiate new objects out of them. So native function constructors. Okay, so this is a list of all the different native function constructors we have, using which you can instantiate no instances. For example, we looked at object, we looked at function. JavaScript makes use of function internally to convert our code into objects. And object function itself we can use to instantiate blank objects. And these are just some of the other native functions or function constructors. And basically two to eight. So function array, number, boolean, date, and goes on. The entire list is actually satisfies is a relationship. They are all inheriting from object, which is the base object from which all instances and all objects inherit from, right? Here's a tree diagram of how inheritance happens. So I don't want you guys to pay attention to those internal properties like prototype or proto. Just want you to follow the arrows, and you'll see that you'll notice that array and function and number all inherit from object. And at the very top, if you try to go beyond object, all you see is null. Right? That signifies the end of the tree. So in order to understand more about this model, you need to know a few properties, internal properties like prototype and protois. So prototype, from my earlier slide, where you got an introduction. Prototype is an associated object with any function that you would want to store behavior and state that is common to all instances, right, that you would instantiate. That's basically what a prototype is. It's proto, on the other hand, is a property that points to the prototype object. So this is just really formalities, and I have an analogy in the next slide that will help you guys better understand this. Yeah, and this is just a definition. You can read it if you want, but let's go into the example, right? So this is a comical illustration of these properties, and it'll probably help you guys understand it a lot better. What's happening here is, in order for you to see the prototype, I'm going to ask you to think of that function as a creator, and think of the prototype object as his prophet. Right? This is just a comical example of how you could think of these properties. Think of the prototype object as his prophet, and the create consults the prophet to the prototype property on the function object, and he tells the prophet, tell all my children they have only one creator, right? So he's passing a message on to the prophet, and the prophet is responsible for delivering it to his children. So so the prophet comes down to earth, right? And think of the instances of the creator that get created as humans. We are the new function there. So we are new instances, and we are humans, and us as humans, we have that, need to find, we have that need to consult with someone, right? Than us. So those objects, so as objects, we would want to know what our creator's message was. So then that's when we turn to the prophet. So the prophet delivers the message to us, and how we consult with the prophet is through the proto property. Yeah. So as you can see, the proto property there is asking, where is my creator's prototype? So the creator's prototype is where the message is. So you can think of proto as just an instance property, which will help you find the prototype of the function it got created from. Yeah. And now, so I just wanted to point out in this slide that every function object has two properties, prototype and proto, and every instance, which is really just an object literal, yeah. It just has a proto property, and we'll see how all this connects. Now this is an illustration of a single function, and the idea that so I have used these properties to build this diagram and help you guys understand how function, prototype, and new instances connect to form this bigger picture. So every function, like I said, is an object, right? And it has a prototype property to which you find its prototype object, and these new instances of that function are connected to the prototype through the proto property. Okay. So another thing you guys need to understand here is that all function prototypes are instances of an object function. Now, which means this prototype object itself is an instance of the object function which we saw earlier, the object function that is sitting on the top of the object hierarchy tree. So it's just nothing but an instance of this object function. So then the question comes to mind, then what does the function prototype over here, the prototype object points to? Where does the proto property of the prototype object point to? Right. So would you guys like to take a guess where it points to? The proto property of that object? Anyone? It is an instance of it's an instance of the object constructor. So it should obviously point to the prototype of the object function, right? So what's important about this is you need to note down that the object function up there is actually a constructor, and it has a prototype as well. And the prototype over here, the proto property eventually leads to null because it's the very top of the tree. It is at the very top of the tree. And all objects actually inherit from object.prototype. You guys should know that. So here's the bigger picture. When you have a function, you have an instance, you have its prototype. Every prototype is an instance of a function, an instance of an object. And that's how you sort of put all the objects together to create a single function. And how it inherits all the methods common to all objects or all instances from the object.prototype. Methods like toString thing, methods like that. All of those methods come from object.prototype. So how does prototypal inheritance take place here? Now I told you guys that these objects are connected through properties and through links. But how does an instance actually search and find properties, right? So in classical-based programming, most of these properties are inherited down, right? downwards. But here the property is actually here the pointer actually moves upwards, and if you can't find the property in its instance, it searches the product chain, it turns to its property, and it travels up until it reaches the new prototype object. And if it can't find the property in that prototype object, it's going to keep traveling up until it reaches the very top. And if you can't find what it's looking for in the object or prototype, then it's not there. You get returned and undefined. So here's a practical example. It's a simple example. We have function employee there, name, takes a name, has property. It has a property called name. It's like I said over here, it's referring to its prototype, employee.prototype, and it's adding a method called getName. .getName is equal to this function, and it acts as a method now. So this method actually lives in the prototype object and not in the function. So when you instantiate a new function, you actually only getting that new function on with this name, right? And behavior that is common like getName would be sitting in the prototype object, in its prototype object. So if you try to invoke getName on John, then what's going to happen is it's going to talk to its prototype. It's going to talk to its prototype to get hold of getName, and this diagram should show it to you. So you have name of the employee. When you instantiate it, you get those two objects. And that's the prototype. You have getName, the method in the prototype itself. That's the full picture. So we have looked at single functions, right? We have looked at how a single function connects to the object function, and how inheritance. There was actually a bit of inheritance taking place there, right, in a single function. We were searching for prototypes in that proto chain from one prototype object, from the function constructor's prototype object to the object prototype. So something I forgot to, I just totally skipped in one of my previous slides is the function. Even function objects have this property called proto property, because it is itself an object, right? And every object has a proto property. So now, according to ECMAScript, all it states is that every function object should ultimately inherit from object.prototype, but it doesn't say anything in between. So there could be objects in between, and that would vary from JavaScript engine from one JavaScript engine to another JavaScript. So before we look at multiple inheritance, I first have to show you guys what the object.create method does. So this method is found on the object constructor and on its prototype. This is why you invoke it as such. Object as capital O, create. So what it basically does is it creates a new object instance for you, and it takes in a it takes an argument in there, right? So a prototype, and it's an argument, and what the argument you generally pass in there is a prototype object, and we'll see what. And what it does is it forms this link, a new object. It takes the property of that new object and it links to the prototype object you passed into. So here's function 1 which I'm declaring, and this is what it gets converted into. Right? You have a function you get function 1 prototype, you get the object.prototype, and with function 2, what I'm doing is with function 2, what I'm doing is I'm declaring a function 2, and then I'm connecting the prototype of function 2 with function 1's prototype. And how I do that is using that method I just showed you guys, object.create. So it introduces a new object, and it hooks up the function 1's prototype as you pass it into the as an argument there. So it's the same process here with function 3. I'm hooking up function 3's prototype to function 2's prototype, and we go on like that, right? And this is multiple inheritance happening right here now. So yeah, now if I instantiate an object from function 3, its proto property would connect up that chain, like as you see in this diagram here. And if it needs if it needs some method or any attribute, it would search this proto chain you see building up over here to find the attribute. So and ultimately it would reach object.prototype. So this is what we call prototypal inheritance, because we are all dealing with prototype objects here and not instances of any class or any function. It's all with prototype objects, and it's all thanks to this proto property of every object here. Some might consider this the proto chain, prototypal chain, goes by some names. Alright, now I want to just touch a bit on what object typing is. Now we don't have classes, right? But we have functions in this prototypal model. But so you would think it's JavaScript being a typeless language. You would think that there's no object typing, but that's not true, because according to this diagram, we actually see a hierarchy, and we do have super functions and functions, and we actually have a function hierarchy, right? And we can create it as we go on, as we go. So there is object typing, and this typing is very dynamic. It can change, and it can be changed by you if you want. So what object typing is all about is defining a set relationship, right? And how you check for these particular types by using the instance of operator. And if you want to find out if an instance of function 3 is actually if that is an instance of, say, function 1 or function 2 or function 3, you would invoke instance of operator according to this example I have shown over here. And if it happens to be that function you're comparing that instance to happens to be in this chain, then it's going to return true, and it's valid. It's valid, right? Because the prototype object it's connected. The prototype object of that particular function exists somewhere higher up on the chain, so it is inheriting certain properties of that object. Therefore, it's in all fairness, it can be considered an instance of that function constructor. So yeah, that brings me to the end. Yeah, bring me to the end of the session. So, any questions? Yes. Yeah.
Lakmal, you said class-based model is not flexible, and prototype-based model is more flexible.
Yeah.
And I think you told that because those pointers are live and updatable during execution.
Yeah.
So what happens? So then, what happens to the object type when the instance of a new instance's proto property is points to null? Will it lose all the type information?
So you mean if I create an instance from any one of these functions, while in this hierarchy, and I go myself, since it's a dynamic function, since it's all very dynamic, I can, if I point it to null, the instance I create, if I point its proto to null, you will lose all its type information. because then it will have a new chain when you modify the chain is very much live, and all your type information is there, so it won't be inheriting any more of those previous properties would have.
So we can no longer consider it as object.
No, it is not. It is an object. It doesn't lose its link to object.prototype. Yeah. So what would happen is if you try to connect an instance of proto to null, by default JavaScript will intercept them and it actually give the proto link the object.prototype, which is the super object or the object with capital O. It would give that prototype object to the new instance, and it would complete that one. Otherwise, an instance can't stand alone without those particular properties in the object.prototype.
Does it support multiple instances?
Okay, so what you see here is pretty much single inheritance, right? Because you're inheriting from one particular object. But yeah, you could make this model support multiple inheritance by, but it would involve a bit of functional code where you would pass two of the prototype objects into functional code, and you would have to loop through each and every one of those attributes and create a new object, a new prototype object. And you would need to have, as a result, that object you would have to add it to the proto property of that instance. So that way you could do it, but it's kind of a hack. I guess natively you don't get support. Anything else?
Are there any means to implement equivalence to the typical design patterns we would have with the class-based model with the prototype system?
Oh, sorry, can you?
Are there any means to implement equivalence to the typical design patterns we
Yeah. There's all the concepts you get with your typical class-based model, design patterns, everything can be implemented using JavaScript. Not this prototype model alone. You have to combine the prototype model with the functional side of this language in order to achieve those features, those concepts. Everything is there, but it's a bit of extra code, and some consider those hacks, but you can still achieve everything you get with classical class-based models.